All right, we're going to be doing some work with interpreting quadratic relations. And here there's not really any new skills, so the best way to kind of look at what we're going to be exploring is to go through some examples with it. And really all this is about is taking what we know and now applying it to real-world concepts. So the first example we're going to look at involves applying that concept to the height of a soccer ball. So this is the path of a soccer ball, this graph here. It says the y values represent the height and the x values represent the horizontal distance. You can actually kind of picture kicking a soccer ball and having it go along this path. So looking at this graph, what is the maximum height of the ball? It shouldn't be hard. That's our vertex right here, and we can even just see that right on the graph. So what is the point of this vertex? Well, the horizontal distance, our x value is 10, and it goes all the way up to a height of 9. So what's the maximum height? We know our height is the y-axis there. That's what it says right here. So it was 9 meters. How far did the ball travel horizontally to reach this maximum height? So that's asking what is our x value here? So at its maximum height, how far horizontally did it travel? Well, we can just drop right back down. We see that it's at 10. What horizontal distance did the ball travel before hitting the ground? Well, this height is telling us how high is this ball above the ground. So if we follow the path of the soccer ball, eventually it's going to hit the ground right there. So how far did it travel? Well, it traveled all the way from 0 to what looks like 21. So it traveled 21 meters before hitting the ground. And D, good question. At what height was the ball thrown from or kicked from? Well, that's going to be our starting value. So what did we start at? Well, it looks like we started right in the middle of those two things at 1.5. And how do we know? Because that is our horizontal distance at 0. That means we must have kicked the ball or thrown the ball from this height. That's why our graph starts at this height. So that is our starting value. That's 1.5. Okay. We'll look at a similar example here of a grasshopper over time if it jumps off a rock. So what's the maximum height the grasshopper reaches? Now we should be good at this. This is our vertex. And it's always helpful to label the coordinates of our vertex. So our x-coordinate here is 5. Our y-coordinate is 4. So we're at 5, 4. How long does it take to reach this maximum height? Oh, first we got to write down the actual answer to A. What was the maximum height? That is our y value here. So we said that that was going to be 4. How long did it take to get there? Well, that's where our 5 seconds comes into play. What that means is at 5 seconds in this equation, our grasshopper reached a height of 4 meters. How high is the rock the grasshopper jumps from? So that's basically what is our starting value here. And that looks to be right there, that 2 meters. That's what we started off at. That's our y-intercept. And how long does it take the grasshopper to land? Well, it started here, and then it jumped up, and it came all the way back down, eventually landing when the time was 13 seconds. Okay, this one we don't have a graph, so we're going to have to do a little bit of interpretation. It says, what's the maximum height the football reaches? And here we can actually just read it and say, all right, what is the maximum height in our table of values? Well, the biggest number we have here is 5.5. Perfect. How long does it take to reach this maximum height? Well, that's our 10, right? So it took 10. And this is going to be our x. This is our y, as it is in most table of values. So this 10, 5.5 is actually the coordinates of our vertex. So if I asked you, what is the coordinates of our vertex? You could tell me, well, it's 10 and 5.5. How do you know? Well, that's the highest value we have available to us. How high is this football kick from? A very good question. Well, to figure out our starting value, we need to go to our starting data, and that is right here. So before we start, we are at a distance of 0. How high are we at that point? Well, we're at 0 meters, which means we kicked this football from the ground. So it's kicked from the ground. We know that because that is the data given to us here. How long does it take it to land? That question is actually impossible because there's no reference to time here. But I think this question is actually trying to ask, what is the distance when it lands? So we'll ask it distance. So how far away from our starting position did it land? Well, we started off at 0. Eventually that football, we kicked it far, but it's going to have to hit the ground at some point, and that's here. So what's our distance when our height is back at 0? Well, that is our value of 20, so it went 20 meters. Okay, a field goal was attempted from 42 yards out. We can assume the ball is traveling towards the middle of a goalpost, so let's draw this out. So if we're playing football, here's our goalposts here. Nice. And we have our football. Our football is here, and it's going to go up and hopefully through. The path of the ball is modeled by the equation which is given to us here, where h is the height in feet and d is the distance in yards. That makes sense. Was our field goal good? Well, here's what we know. We know that this thing is 10 meters high, or 10 feet high. That's what we're told in the question. We also know that the distance between these things is 42 yards. We kick it from a distance of 42 yards away. So what we can do is we can take this distance and actually put it into our equation. And when we do that, it's going to give us an h value. And if we find out the height is above 10, perfect. Field goal is good. But if the height is 9 or 8 or 7, that means it's below 10, not so good. So let's check it out. Is our field goal good? So we have our equation h equals negative 0.03 d squared plus 1.50 d. Now we're going to take it and we're going to substitute our value in, which is 42 squared plus 1.5 times 42. And you're going to probably need your calculator for that. I'm going to use mine. Times 42 squared plus 1.5 times 42. Whoa, I got a value of 10.08, which is very close, but it is a good field goal. And that's it. How do we know? It's above 10 feet, or 10, yeah, it's above 10 feet. So we know that this is just going to creep over that crossbar and it's going to go in. And that is the end of that. So this is just taking those concepts we already know, applying them to familiar situations, and getting some real world benefits from our math.